Why wait to say? At least I did it my way. Lie way too faced, but in my heart I understand. I made my move, and it was all about you. Now I feel so far removed.
Hey guys, welcome to Math Disciples Vector Addition. In this episode, we'll try to solve another vector addition problem, which is slightly harder compared to the previous one. Let's just jump right into it. In still water, Cheyenne can paddle at a rate of 20 kilometers per hour east. The current in which he paddles has a speed of 3 meters per second from north, meaning the current is going towards south. Before we do anything though, we have to convert the units of kilometers per hour into meters per second in order we have the same units for both of our values. So to do that, we can write 20 kilometers per hour times 1,000 meters per 3,600 seconds, which gives us a value of 5.5 meters per second east, since we're giving the direction of east. So let's look at the questions. Illustrate the question above in form of a vector diagram. There we have our compass, and this one is supposed to be north. Okay, let's draw the vectors in. The first vector, which is 5.5 meters towards east, and the other one is 3 meters per second towards south. Let's move this vector a little up. Okay, that's great. And this will be our resultant vector. Let's just call it vector C. And the direction of this is south, again as illustrated here. And this one is east. The magnitudes are 5.5 and 3. These are the magnitudes. So equals to the magnitude of E equals to the magnitude of vector. Great. Let's move on. At what velocity does heat travel downstream? State the direction in polar form. Okay. First, we have to find the resultant velocity. Again, to find the resultant velocity or the value of c, we have to you have to use a Pythagorean theorem, which state that c equals to the square root of the magnitude of a plus the square of the magnitude of b, which given c equals to 5.5 meters per second square plus 3 square gives us a final value of 6.26 meters per second. Well, this is the magnitude of the resultant velocity, or vector c, but we don't have the direction yet. And not only that, but we are asked to state the direction in polar form. So first of all, we have to find the direction. And to find the direction, or the value of this angle, we can use trigonometry identities as well. Or, well, yeah, it's best to find it using trigonometry identities, and let's use that. So we write tan theta equals opposite, which is, if we find the opposite value. The opposite value here is 3 over adjacent. And to do that, we can just type in the numbers in the calculator. divided by, where is the divide sign? Divided by 5.5 gives us 0.54, and to find the tan of that, we have to find using another calculator. We can write 5.5, and to find tan of that answer. Okay. Where were we? Okay, we were here. Going down. Excuse me for writing this here. Okay. So to find tan -1 0.5 answer, the final answer would be 28. 28.6 degrees. However, this one, if you look at the directions up here, it would be 26 east 26 degrees south. So in order to write it in polar form, we have to draw the diagram. So it's east 28.6 degrees south 8.6, and since this is 90 degrees, we write 26 plus 90 degrees. The direction would be 1181 in polar form. So the final answer would be 6.26 meters per second, 118.6. This is our final answer for the resultant velocity of the boat with the effect that the current has. For more questions, please refer to the other videos that are posted. Thank you.
You are the one thing in my way. You are the one thing in my way.